Hi guys, welcome to GD American School. Our lesson today about how to find the area. Now look and listen.
The essential understanding for this lesson is: the area of a composite figure is the sum of the areas of the shapes that make up the composite figure. The surface area of a three-dimensional figure is the combined surface areas of all faces of the figure. In previous lessons, students used nets to represent the shape and find the surface area of a solid figure. This lesson extends students' skills by having them find the area of a composite two-dimensional figure and the surface area of a complex three-dimensional figure, and to solve problems involving composite figures. This problem is key because students apply both mathematical and spatial reasoning, and they identify and perform several steps to reach a solution. Listen and look for students who begin the problem by calculating the area of the front of the barn. Ask students to describe the most useful method for calculating the area. Listen and look for students who draw a horizontal line to break apart the pentagon into a triangle and a rectangle, and who subtract 11 feet from 15 feet to identify the height of the triangle as 4 feet. Discuss how the area of the pentagon can now be calculated as the sum of two smaller areas. The area of the rectangle is its length of 12 feet times its height of 11 feet, which is equal to 132 square feet. The area of the triangle is 1/2 times its base, which is 12 feet, times its height, which is 4 feet. The product equals 24 square feet. The area of the pentagon is equal to the sum of its parts, or 156 square feet. Point out that Hiromi needs to cover the entire front and back of the barn. Ask students how to calculate the area of the front and back. Listen and look for students who explain that we cannot see the back of the barn in the drawing, but we can assume it has the same shape as the front of the barn. Its area is also 156 square feet, so the two areas together are 312 square feet. Ask students to explain the next step of the solution. Listen and look for students who explain that the total area of the front and back, divided by the area covered by 1 can of paint, equals the number of cans of paint that Hiromi needs to use. Point out that the quotient is 9 and a decimal. Ask students if 9 cans of paint are enough to cover the front and back of the barn. Listen and look for students who state that 9 cans would not be enough to cover the two areas completely. A 10th can would need to be opened and partially used.
Now look and listen to another video for more understanding.
How is finding the area of a composite figure similar to finding surface area? Think about this question during the lesson. A city planner wants all neighborhood parks to have more green space than non-green space. Does this park meet the requirements? Explain. A key part of solving this problem is looking at the relationships between the areas of the parts of the park. How are the areas of the green and non-green spaces related to the total area of the park? Together, the green and non-green spaces make up a rectangular space. The sum of the areas of the green and non-green spaces equals the area of the rectangle. The shape of the non-green space is a composite figure. A composite figure is the combination of two or more geometric shapes. To find the area of the composite figure, divide the park into polygons. We'll label the polygons that make up the non-green space A, B, and C. Use the information given in the diagram to find the dimensions. For example, the rectangular green space has one side length of 12 feet, so the opposite side is also 12 feet. When all the dimensions are determined, we can calculate and then add the areas of the non-green shapes. Rectangle A has a width of 14 feet and a length of 24 feet, so the area is 336 square feet. Rectangle B has width 11 feet and length 24 feet. Its area is 264 square feet. Triangle C is a right triangle, with both legs of length 24 feet. Its area is 288 square feet. The total area of the composite shape is the sum of the partial areas, or 888 square feet. Now find the area of the green space. What operation completes the equation?
Select your answer.
Okay, green area plus non-green area equal area of entire, it means the total park. So we make plus.
The sum of the green and non-green areas is equal to the area of the entire park. Now substitute values into the equation. The non-green area is 888 square feet. The area of the entire park is its length, which is 49 feet, times its width, which is 36 feet. Subtract 888 from both sides of the equation and simplify. The area of the green space is 876 square feet. The park does not meet the requirements since the non-green area, 888 square feet, is greater than the green area, 876 square feet.
Okay, now we move to the practical part for more understanding. See you. Okay, today I will listen about the area of composite figures. Okay, page 469. How to find the area? Here we have a shape, a rectangle, and we want to find the area of part A, B, and C. What is the part A? Part A is a rectangle. If we know the length and width of the rectangle, we can find its area. So it's length 16, but what is its width? Okay, here 7.5, this is the total one. And here, what is the distance here? Okay, to find this one. Okay, I think I'm missing, wait a minute. Okay, yes, we have here 3 meter. So the width equal 3. So the area equal 6 times 3 equals 18 square meters. Part B, what's the length of this one? All 7.5, and you know in a rectangle each opposite two sides are equal, so it's equal 3, and the total 7.5, so the remainder equal 4.5. And here the total is 6, and the distance from here equal 3, so the remainder equal 3. So the area equal, yes, 3 multiplied 4.5 equal 3 times 5 up 1, 12 plus 1 13.5 square meter. Part C is a triangle. The area equal half times base and the height, half times 3 times 3 equals 9 times half equals 4.5. Now we add the total equal 18 plus 13.5 plus 4.5 equal 36 square meter. Okay, another one, a composite figure here. Look, he wants to find the area of shaded figure. At first we draw this line, okay, and we divided this shape into shapes, familiar shapes like triangle, rectangle, and so on. So we draw this one here, and now we have 3 shapes. This part A, B and C. Okay, so part A, here is a rectangle, its length 4 and what its width? Here is 9, so it's 9. Now we know the dimensions of part A. Look to the part B, 8 and 9, so we have the dimensions. Look here to the triangle. This is 9, so equals 9. This is the base, and the height here is the same one, equals 5. Now we can find the area of the three parts. So area of part A equal 4 times 9. 4 times 9 equals 36 square feet. And the part B, its area equal 8 times 9 equals 72 square feet. And the part C equal half times base and the height. Half times 5 times 9 equal 22.5 square feet. So the area of shade part, or area of the total one, shaded one, equal 36 plus 72 plus 22.5. So we add the answer, it will be 130.5 square feet. Here we have a cuboid or a prism. How to find the area of a prism? You know that each opposite two faces are equal in area. So this face of dimensions 15 and 4, its opposite face 15 and 4. And in the bottom here, 4 and 8, and here the same, the bottom and higher one, and another one here is dimensions 8 and 15, and the opposite one also. So we can find the area of each two faces. So the area equal, the first one, the base 4 and 8, so the area equal 4 times 8. But how many bases here have the same dimensions? 2. 4 times 8 times 2 plus, and here a rectangle, its dimensions 4 and 15, so 4 times 15 multiply 2 plus the last one, its dimensions 8 and 15, so 8 times 15 by 2, so we multiply 4 times 8, 32, by 2, 64, plus 4 times 5 equal, yes, equal 60 times 220, plus 2 times 15 equal 30 by 8, 240. Then we add 3 dimensions, it will be 200, 424 square inch. Thank you.